welcome to section 1.1 on classifying numbers. Today we are going to be just working on classifying what numbers and where those numbers exist. Okay, just a quick review of what the note sheet looks like. Always want to put your name up here. Okay, and on the left hand side, any questions, or sometimes I like to put the major topic of a certain part of the note sheet. I like to put that there so that I can find it really easily. And so to start off, we have a few definitions. First one, natural numbers. Okay, natural numbers, what we grew up with. So when we started counting, with these numbers. Okay, things like, when you were a little kid and you started counting, you started at 1, 2, 3, 4, so on and so forth. Specifically, they are positive, non-zero whole numbers. Okay, meaning that there's no fraction or decimal part. Okay, specifically whole numbers. Okay, these numbers are non-negative. Non-negative numbers with, I'm just going to say, no decimal part. Okay. The only addition from natural numbers to whole numbers is that we have now said just non-negative. These ones are only positive up here. The number 0 is neither positive nor is it negative. So 0, 1, 2, 3, and so on. Okay. Integers are positive and negative. I'm going to say including 0. Okay. They're positive and negative numbers with no decimal part. Okay, so this is the first set of numbers that doesn't have a true beginning. Okay, these two sets here start at a specific spot. Okay, this one comes from a never-ending list, and I'm going to go -2, -1, 0, 1, 2, and it keeps going. Okay, it goes on and on forever in both directions. All right. Now, rational numbers. There's a specific definition for it. I'll go ahead and write that. So any number that can be written in the form P over Q, where P and Q are integers. And Q does not equal 0. Okay, we have weird things that happen when we divide by 0. I've shown from time and time again that the universe explodes when you divide by 0, so we can't be doing that. Okay, what this actually sets up are things that we've worked with probably in the past called ratios, and that's kind of where this word rational comes from. You see the word ratio right there. Okay, ratios are often displayed as fractions. Okay, so you think of what is a rational number, what isn't a rational number. Most anything that we work with is a rational number. Okay, to make this list, okay, again, it has no definite starting spot, but just to put some numbers in the middle of our list here, let's go with like -1.5, -1.25. Okay, and there's a million numbers in between here that you can come up with different fractions or even decimal representations. Let's say we have, let's just go -1 there, maybe -0.05. We'll skip to 0. We also have positive numbers here. Maybe it's 1/2, 3/4, 1, 1.25, and the list will go on and on forever. Okay, all these numbers or all these number sets have different symbols that we use to describe them. It's all written in what would be on a computer bold writing, but it's kind of hard to write in bold when you're using a pencil and paper. Okay, so the way we do that is we put a double bar. Yeah, it's a very skinny double bar, but we put a double bar at the start. And for naturals, it starts with an N, so we use the letter N. Okay, double bar has an N there. Whole numbers, put a double bar on the first leg, write a W. Integers, for some strange reason, we use the letter Z. Okay, and we double bar the middle part going down. Rational numbers, again, kind of a strange letter for it, but we use the letter Q. Kind of just put a bar in the middle there. And those are the main sets of numbers that we're going to work with. All these sets are pieces of what's called the real numbers. And the real numbers, we're just going to say for now that they're all numbers that we will work with. Okay. More specifically, we're going to get into what really constitutes as the real numbers, but we need a letter for that also. Real numbers starts with an R, so I'll put a double bar on that first leg and write an R there. Okay. So what we define the real numbers as is the set of all rational and irrational numbers. Okay, rational numbers. Again, we said anything where you can write it as a fraction. Any decimal, and you may have done this in the past, but any decimal can be written as a fraction. Even repeating decimals. That's what this bar over this 1/4 on the 5.14 means. That is a repeating decimal, and that can be written as a fraction. Okay, just like this fraction here, if you were to write it as a decimal, it would be 0.6 repeating. You can plug 2 divided by 3 in on a calculator. It's going to fill up your calculator screen with 6s and probably put a 7 at the end because it rounds up. Okay, 3.125 can be written as a fraction, again, as with 5.14 repeating. For irrational numbers, we look at, most of the time when we take a square root of a prime number or any number that's not a perfect square, okay, any number where when you go square root of the number doesn't give you a whole number answer, that's going to be what we call an irrational number. Along with a number that we know is pi, it's 3.14159, and it just keeps going. Okay, square root of 2, another number that's going to fill up your calculator screen and not have a set pattern to it. If we try this real quick, might be kind of tough to see, but we can go square root of 2. So we get 1.41213, and it just keeps on going and going forever. Whenever we know that a number is irrational and it keeps going, we're going to put at least 3 dots here to tell us that it keeps on going in an irregular pattern. Okay. Now, what we kind of use to describe all these numbers and all these different sets of numbers to kind of keep ourselves straight, I like to use this Venn diagram down below. Okay, as far as the left-hand side goes, this might be a place where I say, hey, this is what we call the number sets. Okay, I know the left side is really just for questions, but I like to know where my number sets are, and that's going to be a vital piece of information. Okay, I like to start from the inside out. The smallest set of numbers that we talked about was the naturals. Okay, Natural numbers, things like 1, 2, 3, and so on. Okay, the next set, it's a little bit bigger. It contains exactly one more number. It starts at 0 and keeps on going. Okay. Now the next set was the first one that we said didn't have a designated starting spot. It is called the integers. So that was our Z. Again, I have no idea why the Greeks decided to use a Z, but they did, and so we just kind of kept it. And that's where you start getting those negative numbers, so -2, -1, 0, 1, and 2. And remember, those go on in both directions. Okay, -564 is an integer. Okay, an integer, sorry. The next biggest set that we talked about are the rational numbers. Okay, I'm just going to throw a few in there. Let's say we have -5/121. I don't know what that is as a decimal. Kind of ugly because the denominator is pretty big. But nevertheless, it's a rational number because I can write it as a fraction. Maybe 0.1579. Okay, again, an ugly decimal, but it can be written as a fraction. All right, and that makes it a rational number. Now, you see here, there's this vertical line. All right, all this stuff's over here. We have a little piece over here, and those are the irrational numbers. Those two things are separate. Okay? There are no rationals that are irrational numbers. Okay? Even though we don't talk about a lot of irrational numbers, there's still a whole bunch of them when you start thinking of square roots. You know, square root of 5. Again, anything that's just not a perfect square. Square root of 3. Those things are all irrational numbers. And then we do have a few special ones like pi. There's a number that's designated as e in mathematics. Okay, and those are both irrational numbers. The set of all rational and irrational numbers makes up the real number system. So on that line out there, we get the real numbers. So as you can kind of see, it's almost similar to a Russian nesting doll with the rational numbers. We have different grades of rational numbers, and we'll start talking about where these numbers exist. If you look at the next page, so our next page says give all of the sets into which the following numbers exist. Okay, 5. Well, when I was little and I was counting, I could get to 5 because I started at 1 and I kept on going. So that means it's a natural number. Anything that's a natural number is also a whole number. Anything that's a whole number is also an integer. Anything that's an integer is also rational. And anything that's rational is also real. So anytime you have any one of these sets, you automatically get the ones that follow. This is the natural order NWZQR. -12 is a negative number. The first time that we introduced negative numbers was in the integers. So this number is an integer. Since it's an integer, it's a rational. Since it's a rational, it's a real. The next one, 5 2/3. Well, I can write that in the form P over Q. If you don't remember how to change a mixed number into an improper fraction, you're going to multiply the denominator by the whole number. 3 times 5 is 15. And add the top number. So 15 plus 2 is 17. So we have 17 over 3. That's in that form P over Q. 17 and 3 are both integers, so it falls into the rational numbers. So since it's rational, it's also real. Excuse me. This number here, -2.154 ... means it goes on forever in no distinct pattern. Okay, so we know anything that doesn't have a distinct pattern is an irrational number. And then we also said irrational numbers are also real. Okay, the next set of couple problems here. Give the most specific number set into which the number exists. Okay, so here, if I was going to make this list for these numbers, I'd be looking at the far left number. So let me start off negative 35. Well, it's a negative number with no decimal part. So it's an integer. It's a rational. Since it's rational, it's real. When we want to give the most specific number set, we want to go with the first set of our list. Okay? And so what I'm going to say as my answer is just the integers. Okay? Even though I know that it's a rational and a real, that doesn't tell me as much information as an integer does. So we go with the most specific one. 3.25, well, that's an ending decimal. Since it ends, that means that I can write it as a fraction if I want to. 3 1/4 is what it would be. I could turn that into an improper fraction if I needed to. Remember, multiply and then add. 4 times 3 is 12, plus 1 is 13. 13 over 4. That's an integer, and that's an integer, so we're good to go. Okay, that means that it's a rational number. Even though I know since it's rational, it's also real, I don't need to write that because it just asks for the most specific set. All right, the last one here, 0. I want you to go ahead and pause the video and think about what the most specific set that one fits into would be. Pause it. Do it. All right, welcome back. Hopefully you realize that the first time we introduced 0 was in the whole numbers. Okay, so that is a whole number. Since it's a whole number, it's an integer, rational, and real number. But all I'm worried about is the most specific one, whole numbers. All right, last section here. We're talking about ordering the numbers from least to greatest. Okay, my smallest number here, if I were to draw a number line and put all these on the number line, -4 would be the one that was furthest to the left. So my first number should be -4. And then I don't have any more negatives, so the next number would be 0. And I have 1 point, I'm going to cross these off as I go. I have 1.6 and 1 left. 1 is smaller than 1.6. So I'll get 1 and 1.6. Cross those off. Okay. In this next little bit here, we're kind of mixing up some decimals and fractions. That's okay. We can do that. First, I want to look at negative numbers. I know that they're always smallest. Okay, the smallest negative number I have here. If I want to get this to look, maybe I want to look at all decimals. Okay, -2/3. I can figure out what that is. By using a calculator, I can go -2 divided by 3. Gives me -0.6666, a bunch of sixes, a 7 on the end because the calculator wants to round it up because the next number would be a 6. So I'm just going to write 0.66, okay, and that 6 repeats. I can do the same thing with the 1/3, go 1 divided by 3. And that gives me 0.333 all the way on forever. Let's say it's 0.3 repeating. Okay. Now let's see what's the smallest number here. I have them all in decimal form, so it should be a little bit easier. My smallest one is -1. Okay, that's my least, or my smallest number on the number line. Next, I have kind of an issue here because I have -0.6 repeating. And I have -0.6. So the question is, which one is actually smaller? Okay, this one is -0.60. There would be a 0 after the 6. So what I actually get is that this one is a little bit farther to the left because there's something more added on there. So I have my -0.6 repeating. And then I have my -0.6 without the repeating. Let me get rid of all those. And I'm left with one more, and it's a positive number. It's 1/3, or 0.3 repeating. Okay. I really want these in the form that the problem gave them to me in, so I'm going to rewrite it as -1. Negative 0.6 repeating was -2/3. And then I have my negative 0.6, and then my 1/3. Okay, that should be what your final answer looks like. I want you to pause the video, do the next problem. Go. And welcome back. Okay, hopefully that pausing the video and giving you an opportunity to do these problems kind of helps you out. You should have gotten that negative 1.66 is smaller than negative 1.6. 5/3 would show as a decimal as 1.66. It's positive. Okay, 1.6 repeating. So that's my next one, 1.6 repeating. And then my 16 is obviously the biggest one in that list. Just to rewrite it in the form of the problem, we had that as 5/3 and then 16. All right, so that's the day's worth of notes. At the end of every note section, you want to summarize your notes down here. I'm going to help you out on this one since it is our first day. The summary of your notes should talk something about number sets. There we had the naturals, wholes, integers, rationals, irrationals, and all those form the reals. Okay. And if you wanted to put some examples of these numbers over here, that wouldn't be a bad idea. Okay, real quick. Okay, and rationals, irrationals, those are fine. Reals, all these consist or make up the reals. And then we talked a little bit about ordering numbers. I might say when ordering numbers, we usually have an easier time with decimals than fractions. So turn all numbers to decimals. Then order them. So then order. Okay. Been great talking with you guys. I'll see you in section 1.2. Good luck on that mastery check.
In the beginning there was one, we started counting, it was so much fun. Then came 2 and 3 and 4, we kept on going, there were so many more. These are called the natural numbers, if you don't know them that's a bummer. There are more numbers out there, let's include them and make it fair. Then we add 0 to the list, cause it was about to wave its fist. It was starting to get mad, a bigger list wouldn't be so bad. These are called the whole numbers, if you don't know them that's a bummer. There are more numbers out there, let's include them and make it fair. Next we add the scary part, negative numbers are about to start. -1, -2, let's go, remember it's negative not minus though. These are called the integers, you got to know them that's for sure. There are more numbers out there, let's include them and make it fair.
All right, now I just want to let you guys end off with a little video that's kind of funny, and I've sped it up a little bit, so hopefully it doesn't kill you too much, but it's a good way to remember what we're doing here.
Now we add numbers that are longer, put them all together and they'll be stronger. These numbers can be written as fractions, and decimals and will have repeating actions. These are called the rational numbers, if you don't know them that's a bummer. There are more numbers out there, let's include them and make it fair. Let's do the numbers that are different from the rest, going on forever is what they do best. Say them in one breath and you'll turn blue, these include pi, and square root 2. These are called the irrational numbers, so join them with the rest cause they are bummers. There are more numbers out there, let's include them and make it fair. This next group joins everything as one. After we learn this, the basics done. Natural, whole numbers, integers, rational, irrational, they're all in there, I'm sure. All of this together gives a real number, so don't forget it cause that's a bummer. There are more numbers out there, I'll let you discover them cause they're more rare.